Good morning, everyone. Let's start this session. So in the last lecture, we have seen the hydrostatic force acting on the vertical plane, which is submerged in the liquid. Okay. So for the calculation of the hydrostatic force, we use the hydrostatic law. So suppose this is the free surface of the liquid. Okay. And there is one object which is rectangular in the shape. And this object is completely submerged in this liquid. Okay. So here we have the liquid. And here we want to find out what is the force acting on this rectangular plane. Okay. So this total force, this is called as a total pressure. So total pressure is nothing but the F value. And this force, its equation, F is equal to rho G A H bar, where A is the total area of that submerged surface. H bar is the distance of center of gravity with respect to the free surface. So for this rectangle, we know the center of gravity. So the center of gravity will be exactly at the center. Okay. So if you measure the distance of this center of gravity with respect to the free surface, so it is nothing but the H bar value. Okay, so this is the H bar value. We can calculate the area. Rho is the density of the liquid. For water, it is 1000. And by using this formula, we can find out the total force. So if I draw the side view, so that object in the side view will be just a line. And this is the free surface of the liquid. So total pressure, that is nothing but the force, it will act at this point. Sorry, not at this point. So it will act at the point which is called as a center of pressure. Okay. So the center of pressure, so this is the total pressure, which is the F, that is nothing but this force. So this point with respect to the free surface, it is represented as a H star. Okay, so this H star height, this is called as a center of pressure. So center of pressure, this is a H star, that is a distance of this force point with respect to free surface. Okay, so it is denoted as a point P. So on this plate, this point will be here. So this is P, which is the center of pressure. And this distance with respect to free surface is the H star. So we can find out the H star by using this formula, which is equal to this Ig upon AH bar plus H bar. Okay. So here in this formula, this Ig is the area moment of inertia of this rectangular surface or any other surface about its center of gravity. Okay, so right now this is a rectangle. So in the last lecture, I have shown different area and their center of gravity, sorry, their moment of inertia about the center of gravity. So for the rectangle, this is the centroidal axis. This is CG. Okay. So if this height is a D and this is a P, then moment of inertia about center of gravity, it is given by this formula, which is a BD cube by 12. Okay, so this formula is just for rectangle. Okay. Similarly, if you have another area which is circle, so you can use the formula Ig for the circle. So in this way, you can find out the H star value and the total pressure, which is the F value. Okay. So these are some standard formulae for the plane surface, which is a rectangle. Formula is BD cube by 12. Okay. For the triangle, the formula is BH cube by 36. This is about center of gravity. Okay. Then for the circle, we have pi d square by 4. Sorry, this is the area, and this pi d raised to 4 upon 64. This is the center of gravity moment of inertia, which is the Ij value. This is for trapezium. Okay. So these are some standard formulae that we will use when we solve the problem. Okay, so note down the first problem. So we have one rectangular plane surface with 2 meter wide and 3 meter deep. It lies in a vertical plane in the water. That means the rectangular plane surface is exactly vertical in the water. Determine the total pressure and the position of center of pressure on the plane. So total pressure means F value and the center of pressure. Center of pressure means H star value. Okay. On the plane surface. When, so there are two conditions. First condition is the upper edge of that rectangular upper edge of rectangular surface is coinciding with the water surface. And second, it is 2.5 meter. That means upper edge is 2.5 meter below the water surface. So these are the two conditions given. Okay, so just refer the first condition when the upper edge of the rectangular surface coinciding with the water surface. So what is given here? This is the free surface of the water. Okay. So this is the free surface. And there is rectangular plane or plane surface which is submerged. So this is the rectangular plate. So this upper edge of that plate is coinciding with the water surface. Okay, so this is the condition given. Now what is the dimension of the plate? 2.5 meter wide, 3 meter deep. So this is 2.5 and this total, that is the height, is 3 meter. I will draw the side view. So side view is nothing but just the line. Okay. Now question is we have to find out total pressure and the center of pressure. So we are solving this for the first condition. So total pressure, which is the F value, its formula is rho G A H bar. Okay. So A is the area of the plate. So what is the area? 2.5 into 3 meter. So this is 7.5 meters square. Then H bar is the distance of center of gravity. So first we have to find out the center of gravity for this submerged area. So this is the center of gravity. So this distance with respect to free surface, this is the H bar value. So right now total is 3 meter. So H bar will be 1.5. Sorry, this is 2 meter. So this is 6 meter, 6 meter square. H bar is 1.5. So total pressure, which is equal to, now the liquid, this is the water. So your density value, it is a 1000 kg per meter cube. Okay. So rho is 1000 into G is 9.81 into area is 6 and H bar value is 1.5. So if you calculate this value, then it is equal to 88,290 Newton. Okay. So this is the total pressure for the first condition. Now we have to find out at what distance this total pressure will act on this plate. Okay. So for that we have to find out the center of pressure. So which is the value H star. So center of pressure we can find out by using this formula. So we have to remember this formula. One is for F and second for H star. So this is equal to Ig upon AH bar plus H bar. So we have to find out the value of Ig. So here Ig is equal to, so we will take BD cube by 12 as it is a rectangle, BD cube upon 12. So this moment of inertia is about this axis, which is the centroidal axis. I will assume this to be XX. Okay. So B is 2 meter, this distance. D is the depth, which is a 3 meter. Okay. So this value will be 4.5 meter raised to 4. Okay, don't write here kg meter square. Kg meter square is the mass moment of inertia. And here we calculate the area moment of inertia. Okay, so we have got the value of Ig, which is a 4.5. Area, which is a submerged area of the plane surface, which is equal to 6. H bar value is 1.5 plus 1.5. Okay. So you will get the value to be 2 meter. So this is the value of H star. So H star will be acting at H star is at 2 meter distance with respect to this free surface. So H bar value is 1.5. So H star will be somewhere here at 2 meter. So this is called as the center of pressure. So with respect to this free surface of the water, this is the H star value. So you can see here in the side view, total pressure will be like this. This is your F value. This is center of gravity. This is center of pressure. Okay. So this is the first case. In the second case, this rectangular plane surface is at 2.5 meter below the water surface. So this is the free surface of the water. Okay, so this is the condition given. From this free surface of water, this top edge of this rectangular surface is 2.5 meter below. Okay, and now we have to find out what is the total pressure and the center of pressure. So total pressure, which is the F value, it is equal to rho g A h bar. Now area, it is the submerged area. So area is nothing but this total area, which is 2 into 3. So it remains same 6 meters square. But h bar value, it will change. So first step is find out the center of gravity for this surface. So this is the center of gravity. Okay, so this center of gravity with respect to the top edge of the plate. So it will be at distance. This is 3 meter. So this is 1.5. H bar value we measure with respect to free surface. So center of gravity, this total distance is nothing but h bar value. So h bar is equal to, already we have 2.5 meter plus this 1.5. So this is equal to 4 meter. And then calculate the F value. So 1000 is the water density. This is 9.81. Area is 6 and h bar value, this is 4 meter. So you will get the answer 23,500. Sorry, 2,35,440 Newton. So you can observe here the change in the total pressure. So as we move that rectangular plate, okay. So that means as we increase the depth of this plane, then the force will increase. So this is total pressure, and the center of pressure, which is the H star value, this is equal to Ig upon AH bar plus H bar. So Ig, it will remain same, which is a BD cube by 12 only. So we have already calculated this value, which is a 4.5 meter raised to 4th. H bar is 4 meter for this condition. So this is 4.5. Area is 6. H bar is 4 and plus 4. So you will get H star value. This is 4.1875. So your center of pressure is acting at this point. And this is the H star value. Okay. Okay, note down the next problem. A circular opening having 3-meter diameter in a vertical side of the tank is close by a disc of 3-meter diameter, which can rotate about a horizontal diameter. Then calculate. First is the force on the disc, and second, the torque required to maintain the disc in the equilibrium in the vertical position when the head of water above the horizontal diameter is 4 meter. So we have to find out the torque required to maintain the disc in equilibrium in the vertical plane when the head of water above the diameter is 4 meter. Okay, so this is the given condition. So what is given? There is one tank, and on the vertical side of the tank there is one opening. That means there is one circular hole which is having 3-meter diameter, and that circular hole, it is close by the disc having the 3-meter diameter. So just imagine, I will draw one 3-dimension. So this is one tank. Okay, and in this tank there is a water, and here we have the opening, okay, which is a circular, and it is close by so this opening, it is close by the circular disc. So this is the disc. Okay, so this disc, it is free to rotate about its horizontal diameter. So this is the horizontal diameter. Okay, that means the disc must be hinged at these 2 points. Okay, so I will draw the side view of the disc. So disc is hinged at this point so that it can rotate like this. Okay, now what is condition given? There is a water up to 4-meter height from the center horizontal diameter. So this water height in the tank, so this is the water level. So this is given as a 4 meter. And we have to find out first the force on the disc. So this is the hydrostatic force or total pressure. And second, torque required to maintain the equilibrium. Okay. So first we will try to find out the total pressure. So I will draw the side view. Okay, so it will be just a two-dimensional diagram. So here we have the gate or that disk. Okay. So this is the water level. From this center point, this water level, it is 4 meter. Okay. This disk, it is having the diameter 3 meter. Okay. Now for the center of pressure, sorry, total pressure, we have the formula which is rho g a h bar. So as the disk is circular, okay, this is the shape of the disk. Area will be pi by 4 d square. So this is pi by 4 and d is 3 meter. So that area is 7.068 meters square. Now this h bar value, h bar means what? We have to find out first center of gravity of that surface which is submerged in the liquid, and we have to measure that center of gravity with respect to free surface. So for the disk, this point is nothing but the center of gravity. Okay. So for the circle, its center of gravity will be at its center only. So this is the G point. Measure this point with respect to free surface. So it becomes the h bar value. Okay, so h bar, this value is directly 4 meter. Okay, so put this value in this equation. So 1000 into 9.81 into area is 7.0685 into 4 meter. Okay, so you will get the answer 2,77,368 Newton. So this is your first answer, the force on the disk. Okay, so this is the force on the disk. So this force will act somewhere here. This is called as a center of pressure. And this is the force vector, which is the total pressure. That is a F. Now we have to find out at what distance, that is the distance of P with respect to this free surface. That is called as a H star value. It is a center of pressure. Okay, so center of pressure. So the second question is not to find out center of pressure, we have to find out the torque. But to find out this torque, we have to first find out what is the center of pressure. That is a point of application. So H star you can find out as this Ig upon AH bar plus H bar. So for this circle, about its diameter, the formula for moment of inertia. So about this axis, we have the Ig value, which is equal to pi d raised to 4th upon 64. Okay. So by using this formula, you can calculate the Ig value. So here Ig will be 5d raised to 4th upon 64. Area we have just calculated 7.068 into h bar is 4 meter plus 4. Okay. So if you solve this, you will get h star. This value is equal to 4.14 meter. So h star is 4.14 meter. Now this force, it will create the moment. Okay. So here we have that disk. So this is just a side view. Okay. Then this is the center point, which is a hinge point. So that means about this point, if I draw the rotation, then this can rotate like this about this hinge point. This is the equilibrium. So we can rotate the disk in this direction. Now on this disk, we have the total force, which is called as a total pressure, which is a F. Okay. And here we have the free surface of the liquid. From this free surface, this total distance is a h star. This point is point P. Okay. About this distance is 4 meter. It is given in the problem. This center point is at distance 4 meter. Now this force will create the moment about this hinge point. Okay. So that moment we can find out. So this moment will be, right now it is anti-clockwise. So for the moment, I will write here the moment created by F about the hinge point. So I will assume this to be O. So hinge point O. So this moment is equal to the force F into the perpendicular distance from the hinge point. That means we have to measure distance OP. This is called as a moment R. Okay. So this distance is h star minus 4. So this is h star minus 4 meter. So F is just we have calculated. This is 2,77,368 Newton into h star value, which is a 4.14 minus 4. So you will get the moment value, which is equal to 38,831 Newton meter. Okay, so this is the external moment. Because of this moment, this disk, it will rotate. Okay, and it will rotate like this. So disk will rotate like this in the anti-clockwise direction. Okay, because of this force F. Now to maintain the vertical equilibrium, that means this position, we need to provide the moment which is clockwise, that will oppose the external moment. Okay, so this clockwise moment, it will have the same value. So it must be equal to the external moment, just direction is clockwise. Okay, so your answer will be, what is the torque required? Okay, so torque is equal to 38,831 Newton meter in the clockwise direction about the horizontal diameter or about the O point. That is your final answer.